Question number 42. The function h of t equals negative 16t squared plus 30t plus 5, and that function models the height of a football over time. Where h of t is feet, make sure you see the unit of measure, class, is feet above the ground, and t is the number of seconds after the football has been thrown. Answer the following questions with complete sentences. What was the starting height of the football? Class, one of the things we learned in the class on a standard form quadratic is the starting height is right here. The starting height is your c value. Okay, the starting height was 5, and you better put the right unit of measure, feet. 5 feet. Alright, and let's take a look at the next question. What was the initial velocity? Well, class, this is velocity. Remember, this is v, and if we want to label this one, this is h sub 0, which is the starting height. So the velocity is with the b term, which is that middle term. So the velocity is 30. So the initial, notice I'm using the question to write my answer. The initial velocity was 30. Now velocity is in distance over time, so 30 meters per second, because we're using, I put meters. It's actually feet. Good thing I checked my question. It's 30 feet per second, because our unit of measure of distance or height is feet and our time is seconds. And there we go with question number 42. Question number 43. Well, this question looks exactly the same. Not much of a challenge. The function f of x equals negative 5x squared plus 5x plus 3.5, and that models the height of a diver over time. So height over time, where f of x is meters above the water, x is the number of seconds after the diver has jumped. Answer the following questions in complete sentences. What was the starting height of the diver? This is not very difficult, class. The starting height is the c value. And let's just get this out of the way. The starting velocity is the b value. And where I'm getting a value and b value, here is your standard form quadratic. Let's write that with a y value. Y is equal to ax squared plus bx plus c. The velocity is in the b position. The initial height is in the c position. What was the starting height of the diver? I don't know how bored you are at this point. This is so simple. The starting height was 3.5. Our unit of measure is meters. It's actually pretty high up. Okay, what was the initial velocity? The initial velocity was, and that comes from our b term, was 5, and we have meters, and our unit of measure for time is seconds, so meters per second. That's 42 and 43. Let's see if we get a better challenge in number 44 or not. 44, the function, I won't even read that, models the height of a diver over time, where f of x is meters above the water and x is the number of seconds. Sounds a lot like the previous diver question, but the questions they're asking us are different. At what time is a diver at its highest point? Well, class, let's just think about this. Let's look at a graph. Let's say that the diver starts right here at a diving board, and they're jumping in, and this parabola models time and height. I'll just put ht. And so as that parabola goes, let's say that the diver jumps off a springboard, they go up in height as time goes by, and then they eventually start going down in height, and eventually they hit the water. Now think about this. The vertex is the location for the highest point, okay, and the time that they reach the highest point. So when you look at what time is the diver at its highest point, the time is our h value. And because our h value is the x value of the parabola. This is h comma k. There's our vertex. H is our highest point. And look at this. How high is the diver's highest point? Well, that's the k value. That's the value from the y-axis, which is our k value. So all we're looking at here is looking at h and k. So what time is the diver at the highest point? The diver is at the highest point in 1 second. Oh, I failed to go back and show you that. So look, if the h value is the time, well, h is right here and k is right here. Remember, when you pull out h is going to flip the sign. So in this case, h equals 1 and the k value happens to equal 3. How high is the diver's highest point? The diver's highest point is at 3, and we're looking at meters, I believe. Hang on, I'll write that and look at 3 meters. Yes, we are measuring height in meters. So when you're asked for the time at the highest point and the actual highest point, both of those things, class, look at the parabola. That is just your vertex. The vertex is at time. Here's the time, which is the k value. Sorry, the h value of the, I apologize. This is the h value. And the k value determines the height. H and k. H is x, k is the y value. So that's how to answer question number 44. Let's go ahead and try to do number 45. Here is another function. This models the height of a diver over time, where f of t is feet above water and t is the number of seconds. All right, let's see what we get. At what time is the diver at its highest point? We'll think about it again. If here is our parabola that is modeling time on the x-axis and height on the y-axis. At what time is the diver at its highest point? Well, it's exactly at the point where the vertex is. And the vertex is at h comma k, and this is our h value. H value is time on the x-axis, k value is height on the y-axis. In this equation, our h value is positive 1.6. Here's h, and here is k. So what time is the diver at its highest point? Should be, at what time is the diver at his or her highest point? The diver is at their highest point in 1.6 seconds. Now class, I hope you review these for the test so you don't get these two things switched around. Time is on the x-axis. That is the h value. Height is on the y-axis. That is the k value. Okay, now how high is the diver in 2.1 seconds? We got to do a little bit of math here. All they're asking for is f of 2.1. So let's write our equation. Negative 16 times 2.1 minus 1.6 squared plus 10.5 equals. Let's go ahead and bring up our calculator. I'll pull that over the other side. Let's go ahead and plug that in. we've got negative 16 times 2.1 minus 1.6. Close parentheses. We already have a closed parentheses. You know what? I don't know why it put a parenthesis there. Let's change that. Let's try it again. 16, negative 16, parentheses. Let's try this again. Parentheses. 2. I wonder why it's doing that. Oh well, let's just leave it. I think it's correct. Times 2.1 minus 1.6, parentheses squared. That's working. Plus 10.5, and that's hit equal. And we've got, the answer is 6.5, and I've already checked that in advance, and that is correct. So our value is 6.5. So how high is the diver at 2.1 seconds? At 2.1 seconds, the diver is at 6.5, and this is feet. 6.5 feet. 2.1 seconds, a diver is at 6.5 feet. All right, we'll wrap this worksheet up on the next video.